I've been doing iOS for about 8 years, and one of my professional passions is making old things new again. What do I mean by that? Well, can you hear me? Okay. What do I mean by that? Well, every year Apple comes out with wonderful new shiny things, and we gravitate immediately towards them over the old, less glamorous tools. As a result, useful, stable components become more and more overlooked as time goes on. Well, the majority of my presentation today was going to cover tools that have already existed for a long time and how we can leverage them to make beautiful, adaptive apps. So let's talk about the iOS family. In the beginning, it was just the iPhone, 320 by 480, easy. Then we got a second device, okay, still easy. But then the iOS family sort of exploded. And now we have 10 different resolutions. We used to empathize with the Android people, but now we can commiserate with them. But Apple offered a solution, sort of, size classes. For every device, all the dimensions are either regular or compact. So the dimensions are either one or the other, but it's quite a few combinations, especially when you start taking into account split screen. What's sort of even more counterintuitive is the fact that devices like iPhone SE and the largest iPad Pro have the same vertical size class, even though they're hugely different. So this means that designs made for iPhone, is better? That means that designs made for iPhone just don't translate to iPad very well. But should you even bother with the iPad? What's the point? Are most of your users using the iPhone anyway? There are 81 million iPads in US alone. That is about a quarter of the population. Apple has sold over 400 million iPads. The average iPad has 18 free apps and 10 paid-for apps on it. So that is almost 1/3 of the apps running on the iPad have been paid for. And the majority of iPad users spend about 2 hours a day on their iPad. And iPad apps cost more, iPad owners are less sensitive to prices, and on average have higher incomes than iPhone users. So maybe it is worth it. So now let's get to the fun part. What we're going to do is we're going to go through an app, and we're going to adapt it for running on the iPad. It's going to start out not very pretty on iPad, and we're going to make it pretty. This is a sample app I built. It's called Bikini Bottom Directory. That's the name of the town where SpongeBob and his friends live. And so this app, it has a tab bar. It has 3 tabs. One of those tabs houses a grid. 2 other tabs house a list. There will be 1 detail screen, and there will also be a menu screen. And so here are some of the things we're going to cover. We're going to use popovers. We're going to talk about collection view layout. We're going to talk about size classes and their limitations. We're going to talk about collection views that look like table views. We're going to talk about trait collection overrides. We're going to talk about split view controller. And finally, about trait variations. So let's start with the popover. In this app, there's a menu button in the navigation bar. And when you tap it, the menu slides on. As you can see on the bottom of the menu, there's no tab bar. This means that we have a navigation controller in which the tab bar controller lives, rather than the other way around. And I did this for no particular reason other than I could just use the same navigation bar for all the tabs. But this is what the menu looks like on the iPad. It's huge and it's not very pretty. So what we're going to do with it is we're going to present it as a popover. We're going to start by instantiating the menu. We're going to key off of the horizontal size class because on the iPhone we still want to keep pushing it on. And so when we have the regular size class, we will present it as a popover, we will anchor it to the bar button item, and we will present it. And then by default, it will just get pushed on. So this is what will happen on the iPhone. And so now this is what the menu looks like on iPad. But so it looks better, but there's still a lot of empty space at the bottom. So now we need to set the preferred content size. So in the menu view controller, in the view did load, we will calculate the preferred content size and we will set it there. As a result, this is what our menu now looks like. In fact, I think that looks so nice. I want that same behavior on the iPhone after all, because by default, it will just be pushed on, but I want the same popover. So let's go back to iPhone. This was our code for presenting the menu. Let's get rid of the conditionality. But if we just present it as is, it's going to present as a full screen. And we don't want that. So we need to make ourselves the delegate for the popover. So we find the presentation controller. We make ourselves the delegate. And then when we implement that delegate, what we care about is the adaptive presentation style method. So in a compact environment, presentation style can either be full screen or none. Returning none tells the presentation controller to ignore the compact environment and continue using the default presentation style. And in the case of a popover, ignoring the change gives you the same iPad-like popover behavior on all devices. So we want to return none here. So now this is what our menu looks like on the iPhone and on the iPad. That's it for the popover. Now let's talk about collection view layout. So in the first tab, we have a grid of images. On the iPad, it looks like this. So by default, it just worked because we were using collection view with the collection view flow layout. And we set the number of columns to 3. And then in the delegate method, based on that number of columns, we calculated what we wanted to the sizes of the cells to be. But then we rotate the screen, and this happens. All of a sudden, it's only 2 columns instead of 3. That's because we didn't invalidate our layout at any point, and now we're stuck with the size that we provided rather than the number of columns. So we need to invalidate the layout. So we will listen to when the size changes of the view, and we will invalidate it here. Of course, you could just call reload data on the collection view, but that is a more heavy-handed, less efficient approach. Invalidate layout just flags the layout as dirty, and it's updated in the next drawing cycle. This means that calling it multiple times in the same block would not cause additional layout passes. This also means that even though our view is not in its final size by this stage, by the time it will be redrawn, it will be its final size. So now when we rotate the grid, it behaves correctly. But the iPad is very large. Maybe we want more columns on the iPad. Let's go with 4. So again, we do this by conditionally checking the size class and assigning a different number of columns. So now this is what our 2 grids look like. And that was just the basics of collection view layout. And now I want to talk about size classes. So when we show the same screen on iPhone SE, we have the same amount of cells. But iPhone SE has a very small screen, and those cells might look a little bit too small. But remember, we talked about how there are only 2 size classes, so that is very limiting. So what if we made our own size classes? They're not really size classes per se, but what if we made our own thresholds when we wanted, and treated them throughout our app as if it's a size class? So we can make a category, throw in however many different sizes we want, have a variable, and then we can define what we want the width to be based on various thresholds. So for example, here I want extra small for a very small screen, large for the largest iPad, and just small or regular for everything in between. It does seem a little bit silly to hard code numbers like that, I know. We love intrinsically calculated values, and we hate magic numbers. But the bottom line is, what looks good on a small screen will not look good on the big screen. We have to think about more from design point of view. And often designers are the ones coming up with the thresholds at which they want these layouts to change. And I think, in my opinion, the best thing you can do is, with these hard-coded values, is keep them in one spot, keep them well documented, and abstracted away as much as possible. You can also be more explicit and provide actual numerical ranges. This will give you full control and deterministic results. And this is kind of how websites handle responsiveness as well, through CSS media queries. So now, how do we use these size classes? Well, we have our number of columns. Yeah, we have our number of columns. I'm pressing the wrong button. OK, and here we just key off of the size categories that we've defined. And you can use this for anything. If you want to return a different cell on a small screen, or if you want to different number of sections, anything, you can use this for that. So now this is what all the different screens look like with all the different sized cells. So that was our size classes. And now let's talk about collection views that look like table views. Here we have a list in the middle tab. And on the iPad, it looks like this. Well, in their human interface guidelines, Apple recommends using collection views for grid-like image-heavy layouts and table views when the layout is text-heavy. However, if we want multiple columns in a table view, we can't do that. So we're left with no choice but to use a collection view. So unfortunately, this means rewriting this class as a collection view from a table view, which should be easy. So how do we replace a table view with a collection view? So we just make our collection view, and for the cell for our item, we have to make cells that look like table view cells, and that's where we return them. And then we have to conform to the collection view delegate flow layouts and just provide some values initially, like zeros and edges, this will be zeros. And it looks like this initially, which arguably looks worse than it did before, but we're not done yet. So now let's modify the collection view flow layout. So we want to set the proper size of the items. Again, we go off of the trait collection for how many columns we want. So on the iPad, we want to show 2 columns. On the iPhone, we want to keep a single column. And then based on that, we again calculate the cell width and the cell size. We want to calculate the inset. So for iPad, we want to have 100. And for the iPhone, we want it to be 0. We return those insets. That's the margins on left and right. And we also want to give spacing for the section, so there's a little bit of a gap on the iPad, but not on the iPhone. So now our table looks like this, and we have a 2-column table view. So that was collection views that look like tables. And now let's talk about the trait collection override. We will work with that same tab. So the 2 columns look really good, but when you go into split view mode, they don't look as good anymore. The size class is still regular, but some of the text is clipped. So maybe for this case, we want to keep it as size class compact rather than regular. So we could go back and use the same size categories that we've made in place of trait size classes, or we could just override the trait collection for a specific threshold. And here's what I mean. First, we will need to make a container view controller. And the reason we need to do this is because a view controller cannot override its own trait collection, but it can do it for a child. So then we have the child for this view controller, and we will pass it in the initializer. And so then we actually override it by adding the child. So in the view did load, we will add the child subview, add the child, and move the child to parent, and the order here is important. And then we'll make a method to actually update the trait collection. So let's say our threshold is 800, so this will be the width. For anything smaller than that, our size class will be compact. For anything larger, it will be regular. We check if we want to go compact. We decide on the size class based on that. And we create an override trait collection. And then we set this trait collection on the child. And we call this in the trait collection to change. This will take care of the initial state. And we also set it in view will transition to size that will handle all the other cases. And the way we instantiate this view controller is just like this. This is now how we would instantiate that tab. And so now this is our view controller. It's a single column in half-size split view. Yep, that's it for the trait collection override. So now let's talk about the split view controller. In the last tab, we have a list of characters, and when we tap on one of the cells, it displays some details about that character. So this is the classic use case for a split view controller. And currently, on the iPad, it looks like this. So that's not very nice, but the split view controller will do the job. And on the iPad, we will have a master detail situation. On the iPhone, by default, the view controller will be just pushed on. But now we've ran into a problem. Remember when I mentioned that I embedded the tab bar in the navigation bar so that I could reuse that same navigation bar across all? Well, the split view controller is not meant to live in a navigation controller. Doing that impacts the behavior that we get out of the box, where by default, the pushed view controller, we get a pushed view controller for compact horizontal environment. So we need to change our view hierarchy, and we need to make the tab bar at our root and the split view to be housed inside the tab bar controller. This, of course, also means that for all the other tabs, we need to put them into navigation controllers as well. Okay, so now the split view controller. We make our split view controller. We set its display mode. All visible means that the system will put two side-by-side view controllers in every scenario unless we really don't have enough space. Then we set some properties of the split view controller. I've set this just to show its versatility and how much you can do with it. And then we actually set the view controllers, and I've put the master into a navigation controller so that, again, we get that menu button. So now this is what it looks like right out of the box. We hardly had to do any work. As a bonus, this also works on the larger iPhone screen too. The system decides for us when to show the two views side by side. But now we launch it on the iPhone, and upon launch, we keep getting the detail view controller. So why is that? That's the default behavior, and we need to use the split view controller delegate to change it. So we make ourselves the delegate, and in the delegate method, we want to use the split view controller collapse secondary view controller onto primary view controller. So this method is basically asking, when going into compact size class, do you want the secondary view controller to be collapsed into the primary? Or in other words, do you want the detail to be discarded and only the master shown? And in our case, we say yes, because that's what we want. And so upon launch, this is what we have. But now we tap the cells and nothing happened. This is because we didn't actually tie our master to our detail. And so in the cell selection, we make the detail view controller, and we call show detail view controller. And it's a very clever method because it relies on the sender for a specific way of showing. So for example, we are using navigation controller, and the way a navigation controller would show is by pushing. If we don't have a navigation controller, it will just present it in full screen mode instead. So here we go, and we still have to take care of those disclosure indicators because we don't want them there when we're in split view mode. So we will check if it's collapsed, and if it is, we will return disclosure indicator. If not, we will return none. We will make a variable like this, and we will use it in the self-row method, but we will also use it whenever the screen transitions. And we will do it alongside the transition so that it looks nice upon rotation. We'll just do it like this. So here now we have our two detail split view controllers on iPhone and iPad, one with the disclosure indicators, one without. So that was a split view controller. And now let's talk about trait variations. I think this will be for those of us who are more visual and prefer using Interface Builder. So again, this is our detail view controller. You're probably tired of seeing it by now. It looks pretty good on the iPhone, but on the iPad, it's quite bare. So what is the minimum effort we can do to make it look a little bit nicer? So let's use trait variations. So in Interface Builder, you can vary for traits. So you can select a device that you want to make traits for, and you look at its size classes. So there is regular and compact, and you tap vary for traits, and a pop-up comes up, and then you select if you want this to vary for size or for width or for both. And then you can change whatever variations you want. So here I've changed the width and height of the image, I've changed the positioning, and then you just tap done, and now it works. So this is side by side what the iPhone and iPad look like, or more specifically, the regular width and the compact width. And you'll notice that in the regular width, I even added a button. So this does not only apply to layout, you can even add elements that only show up in a specific trait variation. But I should mention a limitation I found. So while this positioning does work for the new views you add, you cannot add and remove constraints in one variation to an existing element. So what I mean by that is if you wanted to move the stack view that's on the screen to the left or to the right of the image, you would have to do it using the constraints that are already there. You can change their constants, but you can't remove or delete new constraints without affecting the other size classes. And this works not only for positions, but also for things like colors and fonts. So let's change the font. We tap the plus button next to the font. Again, we add a variation. And there it is. And now we bump up that number, and the name grows. So now this is what our detail screen looks like. So that's it for trait variations. So now our app looks beautiful, both on iPhone and iPad. And now dessert. So Catalyst is a new software development tool that allows developers to write apps for both macOS and iPadOS. Its release was announced at WWDC this year, and you can now play around with it if you're both running Xcode 11 and Catalina. Please don't think I'm being humble when I say I don't know anything about Catalyst. I know very, very little. I haven't really played around with it much, but what I wanted is to see how far our optimizations will take us without us having to do anything else. So in the project setup, we check off that magic box. And then this is what we have. So the popover is still there. That's great. We can change the size of the screen, and the number of columns will change based on those size classes that we made. We still have our double table view. That's actually a collection view, and it will change how many columns it has. And we still have our split view controller working. We can change the size. So this was the one issue I had, where I thought that going smaller would trigger that view controller going to compact mode, but it didn't. So of course, more work needs to be done there. But my experience with Catalyst was like magic. It really was a checkbox, and something happened. So now we have an app that works on iPhone, on iPad, and even on Mac. So that brings us down to final thoughts. I think it's important to think about the different variations of your designs early on in the process. How should my app look on the iPad? Do I want it to run on the Mac? You need to think about this early on and make those decisions as you're structuring your app. And approach the whole app holistically. Think about what are the different components of my app going to look like on different screens. If I had thought about it when I had started implementing, I wouldn't have had to restructure my entire app architecture. Leverage the various UIKit components that are available to you. From popovers to trait collections, UIKit offers so much support for achieving beautiful adaptive apps. And lastly, explore edge cases. Rotate your device. Invoke split screen. Save yourself the headache early on by thinking about these behaviors early. That brings me to the end. Thank you all so much for being here for my presentation.